Okay, so this is section 6.1, which is going to look at the normal distribution. And 6.1 looks at the standard normal distribution and the z-score. So our review is our normal distribution, or our normal curve, is that symmetrical or bell-shaped curve. It's the most common distribution that we see. And our mean is in the middle. Mean is that M or that mu or U looking shape. And standard deviation is how it's spread out. The z-score is how we standardize that and make it so that we can compare any mean and standard deviation to each other if it's similar things. If you're ever not given a mean or standard deviation, you're going to use 0 for the mean and 1 for the standard deviation. And that is what makes it standard normal. If we do a quick review of what our z-score is, the z is the number of standard deviations away from the mean that we are. To find the z, you do x minus the mean over the standard deviation, and x is just the number that you're given that you're looking for. So for example 1 here, x is normally distributed. That's what tells you you're using a symmetrical curve with a mean of 5 and a standard deviation of 6. If x is 17, find the z-score. So we would plug it in. 17 minus the mean divided by the standard deviation. So 17 minus 5 is 12. And the standard deviation is 6. So 12 divided by 6 is 2. So our z-score would be 2. Pause the video and do the U-try. So x is 1, mean is 12, standard deviation is 3. 1 minus 12 is negative 11, and negative 11 divided by 3 is negative 3.67. So that would be our z-score. All right, let's look at example 2. Some doctors believe that a person can lose 5 pounds on average in a month by reducing their fat intake and exercising consistently. That on average tells us that our mean is 5 pounds. Suppose a weight loss has normal distribution. That's what tells us we're using this normal curve. Let x be the amount of weight lost in pounds by a person in a month. Use a standard deviation of 2 pounds. So let our mean be 5 and our standard deviation of 2. Suppose a person loses 10 pounds in a month. That tells us x is 10. Z equals. So we're going to do 10 minus 5. Let's try this again. 10 minus 5 divided by 2. So 10 minus 5 is 5. 5 divided by 2 is 2.5. So z equals 2.5. And when we're interpreting that, that means we are 2.5 standard deviations above, which is to the right of the mean. So any positive one is to the right of the mean. Let's look at B. Suppose a person gained 3 pounds, which is a negative weight loss. Then z equals, so 3 minus 5 divided by 2. So negative 2 divided by 2 is negative 1. So the z-score is negative 1, which means you are 1 standard deviation to the left of or below the mean. Gained 3 pounds. Nope, I said that wrong. So if you're gaining 3 pounds, I lied. A negative weight loss means you lost negative 3 pounds. So it's negative 3 minus 5, which is negative 8 over 2, which is negative 4. So you are 4 standard deviations to the left. So 1 pound weight loss, you would still be 1 below the mean. So gaining 3, a negative weight loss means you gained negative 3 pounds. Yeah, so I had done that wrong initially. All right, so why don't you pause the video and do the U-try too. Okay, Jerome averages 16 points. So that's a mean of 16 points. Standard deviation of 4 points. Today he scored 10 points. So that's our X. Find and interpret the Z-score. So we're going to do 10 minus 16 over 4. Now make sure if you're typing this in the calculator, you don't just type it straight across. You either hit enter in between or you put parentheses for your numerator so that it does the order of operations correctly, because your Z-score should be negative 1.5. If you get 6, that means you forgot to put the top in parentheses and you only did the 16 divided by 4. So watch for that key piece. So your Z-score should be negative 1.5, which means you are 1.5 standard deviations below, because you're negative, the mean. So he did less than his average. All right. The empirical rule is a rule that describes how data usually falls in that symmetrical curve. So within one standard deviation of the mean, you will see 68% of the data. Meaning if I asked 100 people a question, 68% of their answers will fall within one standard deviation of the middle. 95% of the data falls within 2 standard deviations of the mean. And then 99.7% of the data falls within 3 standard deviations. So if I had a curve and the mean was here, right? Here are my standard deviations. And I asked 100 people a question. 68% of them are going to fall right there. 95% of them are going to fall right there. And 99.7 are going to fall right there. So that's a lot of information that falls within that. Let's look at how that applies. So use the empirical rule to describe the following. So if we're describing the distribution, we're going to say those 3%. So we're going to say 68% are within what 2 data values? 95% are within what 2 data values? And 99.7% are within what 2 data values? So let's see. The mean is 50 and the standard deviation is 6. So we just start at 50. And within 1, we go up 6. So we would go up to 56. And then 50 minus 6 would be down to 44. So 68% fall within 44 to 56. Then we do it again. We go up. So from 56, we go up 6 more. So 56 plus 6 is 62. And then 44 minus 6 is 38. So that range is 95% of the data. And then we do 6 more. So 62 plus 6 is 68. And 38 minus 6 is 32. So 99.7 of our data is going to fall between 32 and 68. All right. Why don't you pause the video and try to answer the you try 3. All right. Suppose a normal distribution has a mean of 25 and a standard deviation of 5. Between what 2 values do 68% of the data lie? So 68% is 1 standard deviation. So we're going to do 25 plus or minus 1 standard deviation. So 25 plus 5 is 30. 25 minus 5 is 20. So 68% of the data are going to be between 20 and 30. All right, let's look at example 4. Oops. From 1984 to 1985, the mean height of 15 to 18-year-old males from Chile was 172.36 centimeters, and the standard deviation was 6.34 centimeters. Let Y be the height of 15 to 18-year-old males in 1984 to 1985. And then it's asking us to find those 3 ranges. So I'm going to start by doing the upper limits. So I'm going to take the mean, 172.36, and I'm going to add 6.34, which is the standard deviation. And that's the upper limit of the 68%. Then I'm going to add the standard deviation again. That's going to be the upper limit of the 95%. And then I'm going to add the standard deviation again. And that's the upper limit of the 99.7. So by adding one standard deviation, a second one, and a third one, I came up with those upper limits. Now I'm going to do the same thing. I'm going to start with the mean, but this time I'm going to subtract the standard deviation to get my lower limits. So I get 166.02. Subtract it again, I get 159.68. And then subtract it again, and I get 153.34. And now I have the three ranges. So pause the video and try the U-Try-4. All right, so we have a mean of 52, standard deviation of 11. So we start at 52 and add 11. So 52 plus 11 is 63. Plus 11 is 74. Plus 11 is 85. So those are our upper limits. And then we do the same thing on the bottom. 52 minus 11 is 41. Minus 11 is 30. Minus 11 is 19. There are three ranges. So that is 6-1. Let me know if you have any questions.